Okay, so here's one last little bit. I didn't find the exact graphic that I was after, but let's just, you'll see sort of the tripod right here.
Of course, the economy is a little bit more complicated than this template suggests. However, laying the short-term debt cycle on top of the long-term debt cycle, and then laying both of them on top of the productivity growth line, gives a reasonably good template for seeing where we've been, where we are now, and where we're probably headed. So, in summary, there are 3 rules of thumb that I'd like you to take away from this. First, don't have debt rise faster than income, because your debt burdens will eventually crush you. Second, don't have income rise faster than productivity, because you'll eventually become uncompetitive. And
what it means is that if incomes rise without productivity, you're not making anything. There's just a few people making money off of money without any real progress, whatever that means. So, yeah, that's what that.
Third, do all that you can to raise your productivity, because in the long run, that's what matters most. This is simple advice for you, and it's simple advice for policymakers. You might be surprised, but most people, including most policymakers, don't pay enough attention to this. This template has worked for me, and I hope it will work for you. Thank you.
Okay, so right now, all we're looking at with these templates is just money. We haven't even really looked at productivity yet. It's just money making more money. All right, so let's call weeks 2 and 3 good for now. I will go through and grade them. And
can you go over the net present value function real quick before we call it quits?
Yeah, which one is that?
The NVP one. Let me see the formula. I have it equals NVP times rate in your value.
Oh, net present value instead of present value?
4.
Okay, sure. Yeah, let's take a look at it. So let's look at, this is problem 4 for week 3. And what we're doing is looking at a couple different options for our project. So let's just kind of start with the information we have. The first one is that we have a discount rate or an interest rate of 7.4%. Pretty straightforward there. We're looking at 5 years, because we know that we're going to have to calculate this in one of 2 ways. Either if we have a low project cost, we get all of the credit at the end, or if we have a higher project cost, we get the tax credit back earlier, 10% in 1 and 2, 5% in 3, 4, and 5. And apparently, this was exactly how Oregon worked when this problem was written. Okay, so there's the threshold, 20,000. Now we know that it's going to cost us 22,000. We've been given that. Project cost is 22,000. These numbers were from last week, so we know that we have operations and maintenance of 1,000. We know that we've got income of 5,000, and we know that the salvage value is 7,000 in year 5. So those are all comfy numbers. Comfy numbers. So in option A, there's our cost, if you will, 22,000. Now let's see where this number comes from. So in option A, we're looking at the value in I-12, which was 6440. Where did that come from? It came from the sum of 7, 8, 9, 10, 11, those 5 values, where did they come from? Okay, so we're looking at the present value of, so this is, we're using the PV function. So the whole point is to say, like, right now, which one has the better value? So we're looking at so we're using that same discount rate every time. We're using G7, which is 1 year. We don't have any annuities, and H7 is the actual payment, and the actual payment comes from this kind of convoluted looking guy. Yeah. Okay, so let's dig into that. So if B8, so if 22,000 is greater than 20,000, then we're looking at 22,000 times 10%. That's where that came from. Otherwise, we're looking at B8 times 0.35. So we know in this case it's always going to be true, and we're going to get the first value. We're going to get the 22,000 times 0.1. So there's 5%.
Well, I didn't use the if statement.
Yeah, so the if statement is kind of the key. The if statement is the key. Let's put it that way. So let's just see how well this thing works. If I go in here and put in 19,000, everything changes. Like that final value comes out instead. If I go in 22,000,
I did that too,
yeah.
but I didn't do the if function.
Well, there's a couple other ways to do it. You could also you wouldn't necessarily have to use the if statement. You could just calculate both values. I mean, you could say what's the tax creditor for option A, what's the tax creditor for option B, and then just see which one is better. So this if statement is allowing us just to do both. So let's review it one more time. So if the initial cost is greater than the threshold,
Okay.
then give me 10%, because that's what the tax calls for. Give me 10% back.
Of
And
the
what-
initial cost.
Of the initial cost, exactly.
Okay.
Give me 10% back right now. If it's not, just give me 35%. Tell me what that is. So it's either 10% each, for year 1 and year 2, or 35%. So you can see this thing works to do both. So if I'm under the threshold, there's my 35%. 35% of 19,000, let's just say, let's make it 15,000. It's going to be about $5,000, 35%. Okay.
And see, and I got that, I got the option A, option B,
Yeah.
but,
So that's what you're going to get in 1 year, and we actually need the present value for that right now. So the present value is the discount rate times the period, which is just 1 year, times the annuity, which is nothing, times the actual payment. So $2,200 in 1 year is the same as $2,048 right now. Okay, so we can do it again, just basically repeat the exercise, except we're looking at that over 2 years. So $2,200 and paid in a lump sum in 2 years is the same as $1,907 right now. Now let's look at these guys. It's the basically the same argument, but you can see what we've done is say, now I'm going to multiply by 0.05.
Right, 'cause
That's your 5% after the third year, or you get nothing. You either get 5% or nothing in that third year. That's why the zeros showed up before. Same deal. Same deal.
you can
Yeah. Copy, paste,
just
boom.
write it down.
Yeah. Okay, so here's the sum of those guys. Sum of those. Oh, and then all I did is the validation. There's your 0.35 times B8, 35%. Times B8. And that's the net present value. So there's the rate before, and then all of the values.
All the PV values.
Yeah, the net present value.
The actual PV.
Yeah, so let's look up NPV really quick, because that's different. So net present value, instead of just having a single annuity, the annuities,
All the-
they're different. Yeah, each year's a little bit different. So there we go. Net present value is similar to the present value. Primary difference is that between NPV is that PV cash flows to begin either at the end or the beginning of the period. Unlike the variable NPV cash values, PVs must be constant. So NPV can be not constant. That's why we can see those. Yeah. Okay, so that's where that comes from. Now here's the here is sort of the magic. Here's the magic. So you can see that the two. Oh, pardon me for just one quick second. Sorry, it's a little bit of an emergency. Yeah. Okay, so what we're looking at right here is the I recommend statement. So what we're looking at is if D13,
That's that 5, 6, 500.
which one?
One highlighted in blue.
Yeah, yes, exactly. If D13 is greater than E13, then pick D6. So if the net present value, if this is a better value, pick it. If not, pick the other one. So since E13 is greater than D13, we select option B, and that's the value that turns right in there.
What I'm struggling to come up with is that 5,565, the net present value is right there.
Okay, so you're,
Got everything else in there.
this is the stickler. Okay, so that's
It's just a sum equation?
well. Let's just look at each one. So this is basically last. This is last week. Salvage value. Salvage value of 48.99 with that 7.4% in 5 years. That's our revenue. It's the present value of the revenue. So I think every single one of these is present value. Present value of $7,000 in 5 years is $48.99. Present value of 5 years of revenue at 5K, 7.4% 4% is 20,000. The present value of these costs is a negative 4,000. And we've calculated we've kind of gone to great lengths. This is the trickiest part to calculate right there, those two numbers.
I got those ones after an hour of work.
Yeah, but there they are. Well, yeah, so it's I-23 is coming out of option B. So we're also doing the net present value of those numbers, year one actual payment is the option B. So it's the same logic. Same logic. So if this threshold, if 19,999 is greater than 20,000, then use the 10%. Otherwise, use the 0.35. And the point is, you're always going to use that 0.35 in option B. And I guess you can sort of see why this would be handier from a utilities point of view, because if you've got a small project, they're like, hey, we'll just pay you at the end. We'll just pay you a small amount at the end. But if it's a big project, like, let's just take care of our debt earlier.
Yeah.
This is kind of nice too. He's got some notes out here. And you can see that to put that equal sign in, without it calculating, he just puts a little quote in front of it. Puts that little apostrophe, which is kind of handy. Just turns off the equal sign.
Just take it out.
It's a good problem though. And I mean, here's the thing. I want to make this pretty clear. Is it, and I've heard this a lot of times too from the tax accountants. So being able to do your mechanical, electrical magic is great. It's this stuff though that really closes the deal, for the decision maker, whoever's trying to make a decision where to put this. Put the panels up. And this is the kind of stuff too that is constantly debated at the legislature in terms of energy law in the state of Montana, where okay, so I'm going to take a pause there. I think we've covered weeks 1, 2, and 3 pretty completely. Actually, I'll just take a stop there. Actually, no, I'll take a stop.